Okay, then you can start.
A very good evening. Respected Principal Dr. Anish Gambar, Administrative Officer Mr. Shantesh Ravrane, Resource Person Professor Onkar Marathe, faculty members and dear students. I am Sandhya Vaingankar, Librarian of SSPM College of Engineering and Secretary of Ndli Life Club, welcoming all of you. Today, the Central Library Department of our college, in association with the National Retail Library of India and the Indian Institute of Technology Kharagpur, is going to present a webinar on electric vehicles. The objective of this webinar is to give introductory knowledge, components of electric vehicles, and use of MATLAB and Simulink in electric vehicles. Professor Onkar Marathe is today's invited speaker. Mr. Onkar Marathe is Assistant Professor and Head of the Department of Electrical Engineering, Sindhudurga Shikshan Prasarak Mandal's College of Engineering, Kantavli, which is affiliated with the University of Mumbai. He has been working as a faculty since 2009. Professor Onkar Marathe received his Masters in Control System from Kekiwat Institute, Nasik in 2012 and his undergraduate degree from SSPN College of Engineering, Kantavli in 2007. His area of interest are power electronics, control systems and electric vehicles. He has got 2 years of industry experience and 13 years experience in teaching. He has conducted 30 days and 45 days internship on electric vehicles. Now, I would like to request our speaker to share his valuable thoughts with our participants. Sir, please take charge of session. Thank you.
Yeah, thank you, ma'am, for such a wonderful introduction. I firstly want to congratulate everybody on Women's Day. Today is Women's Day. 8th of March is celebrated as Women's Day. So I want to congratulate all the women who have been a very big support for us, all men's. And with this, I will start with my electric vehicle presentation. So I will present my PPT. Just give me a minute. Okay, just tell me if you can see this PPT.
Yes, sir.
Okay. So I'm here to present basics of electric vehicle today, and it would be a really interesting session. So today we are going to focus our this webinar on history of electric vehicle, then components of electric vehicle, and we'll gradually move a little bit towards forces and power requirement of electric vehicle. So in a 1 hour seminar, it is very difficult to introduce and take you till the end, but I will try my best to do it. Okay, so starting with our introduction. So as you know, that invention of first electric vehicle took in 1828 by there was a physicist called Ndli. So he invented electric motor and created a car by which he can drive this electric vehicle. But that invention was not much famous. But in 1832 to 1839, there were two Scottish scientists. One of them was Robert Anderson. Okay, so he started doing some experiments, and in 1835, finally, Professor Sebrandus, he was from Netherlands, he developed a very small electric car which was not rechargeable. So once you use that batteries used to be you can say use and throw type of batteries, primary cells. Okay, with this it all started. So after 1835 there was Industrial Revolution 1 which took place. So in Industrial Revolution were there were only mechanical type of instruments that were used, basically steam engine and steam powered substations and all. So in that mechanical engineering development was so huge that this electric vehicle was kept aside. In Industrial Revolution 2.0, there were invention of some mechanical engine, IC engine and diesel engine. So all the focus shifted towards what this diesel and petrol engines. And after that, they were so huge in power requirement and power dissipation and power calculation and all. So that power requirement was very high, and that was easily made by this petrol type of engines. So after that, there was basically no need of any electrical engine because all the requirements were satisfied by mechanical type of instrument, IC engines and all. But nowadays, you can see that we are moving into age where we have lot of problems associated with fuels. So there are very few countries in the world uh, that produce oil, and this oil is of in very few quantity. It is said that by 2050 we will vacant all the oil on the planet. So there will be no oil on the planet by 2050. So if we don't have oil, what is the option we are left behind?
Excuse me, sir.
Yeah. Yes, sir.
Only title your first PPT is showing there, not
Yeah,
quantity.
sir, actually, I'm just giving introduction, so that's
Okay.
why, yeah. So I will move little bit faster afterwards. So uh, PPTs, but they are not relevant right now. So I'm talking about introduction to just EV, and by the time I finish it in 1 or 2 minutes, next 2 minutes, I will move to my main topic. Thank you, sir. So can you say see this PPT? Okay.
Yes.
Oh, yeah, yeah. I will move a little bit afterwards. Okay, so after this, what I'm just telling you about history of electric vehicles. So after that, what happened? There was sudden requirement of power, different power sources and different resources. So what happened is electric vehicle was basically now has become a need of our society. So there are many such type of vehicle. Electric vehicle is one of the technologies. We have hydrogen vehicle. We also have hybrid electric vehicle. I will come to them. So let us go to first vehicle, that is conventional vehicle. So now this conventional vehicle, as you can see, how this conventional vehicle operates. Anyone knows conventional vehicle, regular vehicle, how it operates? It works on basically petrol engine, correct? So IC engine. So there are 4 cycle or 2 cycle. Normally we have 4 cycles. So that 4 cycles are combustion cycles by which a force is produced, and that makes your wheels to move. But these conventional vehicles now are replaced with what? Electric vehicles. So we also have hybrid electric vehicles, and electric vehicles are combined together. Now, what are these hybrid electric vehicles? You can see this vehicle. There is a battery, there is an electric motor, and there is a petrol engine. So the vehicles which operate on both of this, like petrol as well as your electricity, are called hybrid vehicles. At least two of the resources it should have. So some of the vehicles nowadays are having uh, petrol engine and they are having fuel cell. Correct. This is this type of vehicles are there in today's world, and but the only thing is the cost of this vehicle is very high. So you might know that cost will not be a big factor because you know how mobile technologies were evolved. Correct. In 1900s or 1990 to 2000 era, the mobile prices were around 15,000, 20,000 for calling, correct, for monthly call. Then after there were some standards or modifications made, and then the technology was cheaper. So this will happen in electric vehicle and hybrid electric vehicle, but it will take time. Okay, so what we have in hybrid electric vehicles, so we have ideal start and stop type of system. Then we have ideal start stop, brake energy regeneration, torque assistance during acceleration, full electric drive, and autonomous electric vehicle. These are some of the examples what we have in our hybrid electric vehicle. So you can see that these vehicles have got regenerative braking. What do you mean by regenerative braking? When you press brake on your electric vehicle, your energy, instead of stopping the vehicle, what happens? The stopping happens because of electrical motor, and this electrical motor regenerates some electricity and sends it to battery and your vehicle you can say light, LED or AC type of thing. So that means what happens, that during starting we require some energy, and while stopping the energy is saved and it is not taken from battery, while instead of that your battery is charged with this. Okay, nowadays this is development that your vehicles are becoming autonomous electric vehicles. So you might have seen a new model which has come. So Tesla's model, which was Tesla Model 3, which was in 2020 August, it was launched. That model is now autonomous electric vehicle. So it calculates your speed, what is the object which is coming in its way. It calculates by image processing and lot of algorithms, and finally it detects and stops your electric vehicle. Okay. So now this is our model of electric vehicle. So now you might be thinking that how this electric vehicle is charged. So electric vehicle is charged by using a charging device, and this charging setup is can be made either at your home or your charging stations. Okay, so that your vehicle gets charged. Normally charging time from this for this electric vehicle is 7 to 8 hours. Okay, normal charge. And there are some turbo chargers which are installed in US, not in India yet, but in US this technology is used nowadays, and turbochargers can charge it within time of 2 to 3 hours. Okay, so what are the pros and cons of this? So if you have electric vehicle, what will be the pros and cons? So first is your cost of maintenance and control is very less. So maintenance, you hardly have maintenance for your electric vehicle. Only big maintenance comes with a battery. So if you have a battery in your electric vehicle, normally it gets replaced by 3 to 4 years of its usage. So if you use your electric vehicle in the correct manner as mentioned by the manuals of your company manuals, then your battery cost would be lowered. Okay, so next 2 to 3 years, once you buy any electric vehicle, hardly you will have cost of anything. Okay, second is your environmental function. So there are two big reasons for this. One is your lack of conventional fuel option to utilize renewable energy. So you can use this vehicle and you can save a lot of energy. So if you look at the examples nowadays, that if you go to buy any electric vehicle, say two-wheeler, you'll see that within 1 or 2 rupees, you can drive almost 5 to 6 kilometers minimum. So that is how you can save money, as well as you can save on carbon production. Correct. So that amount of petrol, your petrol emission, carbon monoxide, carbon dioxide emissions, you are saving. So that helps for environment to reduce the carbon content and pollution free. Okay, then we have limited. I will come to energy efficiency. For energy efficiency, there is no. There are a lot of power conversion what happens in your electric vehicle. So if you calculate the energy efficiency, it is less. But if you compare it with diesel and petrol engine, it will be very high energy efficiency. Okay, for per unit, as I said, 1 unit of your electricity If you compare it with cost of petrol, then efficiency is high. Otherwise, efficiency is little low. And the second thing is, you can see the limitation that you should have a charging station nearby. Then you should select a distance, what distance you need to travel. So if you take an electric vehicle and say that I'm going to Delhi tomorrow, it is not possible for you, correct? Because there is some distance, and if you go above that distance, it would be very difficult for you to reach that distance. And third very big problem is temperature. So very high temperature and a very low temperature, both can cause your system to stop working. Okay, ideal temperature for batteries is around 0 degree to 25 degree centigrade. Okay, below 0 degree if you go, then it may happen that there will be less free electrons and battery would not give you the same output as that of its ambient condition mentioned by the manufacturer. So we'll come to components now. So electric vehicles has got these three components. You can see first I have divided into three regions. You can see first region is vehicle, body and gear. You can see the structure of electric vehicle. So you can see that there are wheels, vehicle body and gear. This is first. Second is your motor, battery, power control unit and onboard charger. And third is your essential components like your sockets, mirrors, correct, glass body, reflectors. This all comes in your assembly part of your electric vehicle. So all these three are major part, but we would be concentrating on second part, that is motor, battery, power control unit and onboard charger. The other components, that is first and third component, that is vehicle structure and assembly, will be almost similar to your conventional vehicle. There will be no big change. Only thing is that there is a constraint for electric vehicle is that the weight of the electric vehicle should be at the center of your vehicle. So normally batteries, if you see, you cannot keep batteries here or here, correct? You have to keep batteries either on batteries at the center only. This is the constraint. Why? Because there is a center of gravity of this is should be concentrated at center any vehicle. Second important thing is these number one and number three components are very lightweight, because weight is another constraint. Weight of the vehicle is another constraint. So that is why you should keep this in mind. There are few things in design, that this body should be of less weight, then tires should be of size of tire should be less, so that it would not give big resistance to your vehicles. We are going to see that things later. So we'll see parts one by one. This is body, okay, and this is motor, then we have inverter, then we have batteries, and we have onboard charger. Got it? So this is these are the parts. So in this body part, what we have, this motor, you can see this motor. So this motor is coupled with gear arrangement, such that these gears are further connected to your wheels of the vehicle. So now this motor is connected to inverter. You can see there are three terminals here, two terminals here. So two terminals would be coming from your battery, and these three terminals are normally for three-phase motors. Okay, so if the motor is DC motor, you can have two terminals and one would be common terminal, and this is connected further to your batteries. And batteries are you can see that the weight of the battery is highest in electric vehicle. If you just check the weight of the vehicle, it is around 30% of the weight of the electric vehicle is its battery. Okay, and that battery will have some three terminal pins which will be given to your onboard charger. Now this onboard charger is on your vehicle. Okay, you have to just connect a pin from this charger to your socket in your house. Got it? So there are two types of pins you can see here. Either you can give DC supply or you can have AC supply. That depends on manufacturer how he does it. So this is done through your charging station. Got it? We'll see the block diagram of electric vehicle. So vehicle body, as you have seen, then your motor, then motor controller. The motor controller is supplied with power from battery, and you give control signal to motor controller. So now this motor controller is a heart of our electric vehicle. So controller controls the motor. It also does battery management system, and it also takes care of your overall performance of the vehicle. Okay, so now this control signal, who generates the control signal? The driver sitting here. If you press the accelerator, that signal will be converted to an electric signal, and it will be given to your motor controller. So once you press this accelerator, the power will be shifted from through your microcontroller. Power will be sourced from this battery to the motor. Got it? So this is design. So look at the propulsion power, motor size, and battery capacity. So what are these three? So how we are going to design your vehicle? I will just go through that. So you need to keep in mind that it is actually a reverse procedure. Many people, what they do is they first bring a motor, then they take a battery, and they just connect it, and then they sit on that electric vehicle and try to run it. So which is very wrong way of doing calculations. So the correct way of doing calculations is to find out the battery capacity by selecting what amount of weight your vehicle is going to carry. So if you are, even if you are buying any vehicle, so think that in mind, that what weight that vehicle is going to carry. If the weight of the vehicle is very less, you can go for a low cost bike. If your weight is more than 100 kg, 120 kg, you have to go with a higher range and higher motor sizing. Got it? So these are the things which you should keep in your mind when you go for buying any vehicle. So same thing here, the propulsion power is to be considered first. Depending upon that, we'll select a motor size and what should be the battery capacity, so that our motor will run for at least 6 to 7 hours. This will be our battery capacity. So before going to this design, we should understand how our vehicles vehicle basics we should understand, and dynamics we should understand. So I'll go with that first. So this is your vehicle. I hope till this point I am clear. Any doubt up to this we can discuss? If you have any doubt, you can type here in chat. Hope everybody is there with me. Okay, I will continue now with next part of presentation here. Okay. So if you have doubt, you can just put in chat. Okay. So I will continue now. Okay, so vehicle basics we'll start with. So you have any vehicle, let it be conventional vehicle or your electric vehicle, you'll have two forces which will act on this vehicle, correct? Let us go to some mechanical part of this. So there are two forces. One is push force, other is frictional force. Out of this, frictional force has got two components. One is called stiction, that is static friction, and second part is your dynamic friction, which comes when your vehicle is in running phase. Got it? So stiction is very high during starting. So once your motor start, this static friction goes off, and only dynamic component of friction remains. This is about frictional force. The other part is push force. Now the push force is generated by what? In electric vehicle, by motor, correct? The motor gets power from your batteries, and that batteries take this power and move your vehicle. So in order to move the vehicle, this push force should overcome this frictional force. Then and then your vehicle will move, correct? So as the vehicle moves, see, from this to this, there are two components which act on the vehicle. One is gravitational force, of course, and the second force which comes into picture when your static friction goes off is aerodynamic drag force. Now, what is aerodynamic drag force? So it is basically due to the air which is coming on your vehicle. Correct. So there are a lot of designs which you can see that the vehicle height should be minimized in order to reduce this aerodynamic drag force. So you might have seen F1 races. So in that you can see that the driver is sitting at a level very close to the level of ground. Why it is so? That helps to reduce the aerodynamic drag force. And if that happens, your vehicle will take a very good speed. So this aerodynamic drag force is directly proportional to your push force. So as your speed, I can say, so as the speed increases, this aerodynamic drag force goes on increasing. Okay. Gravitational force is constant, so it will not have any change in it. It is mgh, correct? So that same force will act. The frictional force, as I said, that it will go on, and push force. Now, how will you calculate the power which is required for this vehicle? So power is this total force. How will you calculate this force? This force minus this force, correct? We have to resolve this force on x-axis. So frictional force will be minus from your push force, that it will be your total force, and total tractive force into velocity. So force into velocity will give you power of the vehicle. So this is free body diagram. These things you have done in mechanics, so it is easy for you to understand. So now let us have these forces, resolve these forces. Now this was on plain ground, but if I add something to it, like if your vehicle is on a inclined plane, I will say. So either it is moving up or it is going down. In both the cases, you have some forces which act on it. So you see that this is the direction of movement of your vehicle. So what is the force? One force which you already discussed is your aerodynamic force. Correct. It is given by FAERO. Then FRR is your rolling resistance force. So this is your rolling resistance, correct? So it is another type of frictional force which is acting on it. Then we have XFXI, that is your acceleration. You can see here. And this acceleration force comes from again motor. And there is one more, is hill climbing force. So now this climbing force will be a component of your weight, correct? Weight component which is dragging your vehicle downwards. So this is, it is component of your, so there will be two component will be perpendicular to your this plane, and this HC of theta which will be parallel to your this plane, correct? So this, all these forces will be there in picture. So along with this we have linear acceleration and angular acceleration force. So if we have all these forces with us, and we find out what is the our vehicle. So naturally, if your vehicle is moving in upward direction, your force of your, the tractive force is greater, should be always greater than all this force to move your vehicle upwards. So are you getting? So we are calculating first this force. I'll go back a little bit. First we'll calculate this force and calculate the power. So in order this power, we'll design a motor, and to run this motor we'll have a select certain battery capacity. Got it? So I'll come back to again this forces one by one, and then we'll go to calculation part. So you can sense force. Okay, so this is one of the force which comes during the motion of the vehicle. As I said that this will be related, this will be related to your tires. So how to select a tire which will give us a very good value of rolling resistance. What do you mean by good value? If you keep of this resistance, say you can take example of this wheel on rail, correct? Last value you can see here 0.001. If you use this type of wheels for a regular railway track, but on regular basis, what will happen? Your page will be more. will slip more. So you cannot select a very less value, correct? Value which will suit your need. So if you select a very high value for railways, because railway is also, so if you select that for railways, higher resistance value, what will happen? Your vehicle will not, correct? It will give very high resistance. So you select this value, and it depends upon the manufacturer, and you have to select a tire such that you'll get a good resistance. Is it clear? Okay. So you can see that this value varies speed, and if pressure increases, what happens? The decreases. Got it? So there are two factors which affect your tires: speed and other is pressure. So what is the formula for this? This is one type of friction. So mu RR is a coefficient of friction which is constant, the rolling resistance constant. M and G are your weight of the mass of the vehicle, gravitational acceleration. Got it? So this is your rolling resistance force. How do you calculate it? Just multiply this mu into M into G. So if you don't know what is mu RR, you have to calculate it or get it from manufacturer of tire. Okay. So this also depends, I will tell you that it also depends on road, not only on, because if road becomes free, then sometimes it happens that your tire may slip on that. So it also depends on the road as well as tire. Okay. Go to next force. Now this is called as aerodynamic force. So whenever any vehicle is in one direction, there is high pressure on its front front area and low pressure on its back area. So wherever there is low pressure, there is, but wherever there is high pressure, it will resist your motion. Okay. So this, how do you calculate? Calculate it with the formula AD, that is air drag force, is equal to 1/2 into rho into CD into AV squared. So this force is in Newton. So all the units, if you calculate, you will get a, you can check what is air density. So air density depends on the atmosphere. So if you are moving in cold, it will be high air density. Moving in a very hot region, it will have less air density. A is frontal area. So front area of your vehicle, which is square. Then CD coefficient. So drag coefficient depends upon your vehicle design. So as a very height, then you will have big drag coefficient, you will have lower drag coefficient. And last is your velocity of vehicle. So in order to have air drag, what you need, you cannot change air density. So this is not in our hand. Capital A, which is front area, you have to minimize. So whenever you do design of your vehicle, you have to keep in mind, you have to have very less area, frontal area. Okay. Then CD is drag coefficient. As I told you that you have to keep your height of the vehicle minimum, and V is velocity. So it is observed that certain limits of velocity, this is less, but above certain velocities, like above 80 miles per hour or 80, 90 miles per hour, 100 miles per hour, this air drag uh, uh, increases very, correct? It becomes very high, exponentially it increases. So because it is velocity square, you can just, the lower the velocity, you'll have track. This doesn't mean that electric vehicle we should always run at lower speed. It means you have to think of this as a force whenever you are calculating your total force. Okay. So above certain limit, this force is good. So you have to give that amount of power to your motor. So I have discussed aerodynamic drag increases when square of speed as per. Okay. So these are some of the designs. See, old designs and new design. So I have just taken this screenshot from Google. So you can check here that's equal to 0.85. So you look at this car, it is very flat and it has got large frontal surface area. On the other hand, if you go towards new, that is last CD equal to 0.32, you see that it is less front surface area. Height of the car is also less compared to others. Got it? So if you keep your CD, if you have a flat plate type of design, and as your CD, so whole surface will come into picture. You keep a hemisphere type of structure, like you can see car. This is hemisphere type. You will have lesser than your flat plate. If you have a convex type of structure, which you see here in third car, or last car, I can say, and air, you will have very less. What you can say, drag coefficient. So you might have seen, I don't know whether you have seen, that there are some cars which are developed foil design and which move at a speed of 500 miles per hour. So this is there, but they are not able to drive that car on road, but they drive it on ice surface. So you might have seen it in movies. Okay, I will go to next part. So for truck, buses, modern buses and motorcycle coefficient. So for design, we'll take these values. Now we'll come to next force, that is hill climbing force. Now, wherever you are doing hill climbing, there is either rise, you have to run, or you have to put a force so that you can overcome that hill. Correct. So that force is calculated. It is component of your mg. What weight? Correct. So weight component which is resolved along axis. Got it. Resolve that hill climbing force, you'll get FHC is equal to mg sin. Correct. Okay. Mg cos theta will be your downward force and mg sin theta will be your sideways force. So this FHC, you can easily, I think this is, you have done this in your uh, banking calculations. Okay. Next force is your acceleration force. So we'll move little bit faster. So don't go with the formula. Formulas are there and derived already. So I'll not go into detail this formulas. Only thing is linear acceleration. Mass into acceleration is your force. So linear acceleration force is your mass into acceleration. Angular acceleration force, this you need to calculate, which is F omega A, which is where A where eta Q. Eta Q is your gear efficiency. Okay. I is moment of inertia and gear, G is your gear ratio, same as your acceleration which we take in your linear acceleration, and R is radius of tire. So all this, if I add all these forces, what we get? Power, which is required. So total power can be calculated as power is equal to F tractive effort into velocity. So if you get the power calculation, it is addition FRR. RR means what? Rolling resistance plus D, which is your aerodynamic drag force, plus C, which is your hill climbing, FLA omega A. Got it? So these are all the forces what we have related with our electric vehicle or any vehicle, you electric. Correct. But the power requirement we are calculating for electric vehicle. So if you look, add all these forces, you will get total tractive power. How will you get total tractive power? This into velocity. Now, taken this, I've simplified, and all these forces are in front of you. Correct. So just see these forces, and now what we'll do? We'll go to parameters of EV. Okay. So now all these forces required mg, then you can t, then we have a moment of inertia, acceleration. theta, then R is radius of tire. All these things are related with what? Your vehicle specification. So let us go to vehicle specification. So I've taken a vehicle. Let us take a four-wheeler. So its mass is in kg. So I've taken value of mass 1000. Width of the vehicle. So width means what? The area, correct? 1 meter. Oh, sorry, width means the total length of your vehicle is 1 meter. Then height of your vehicle is 1.5 meter. So I've taken it in meters, not in foot. Rolling resistance, I've kept it at 0.02. This depends on tire, as I said you. Air density, I've taken standard value to be 5 kg per meter square. CD, I've taken 0.3. Gravitational force is 9. Speed in kilometer is 40. And frontal is 1.5. And velocity, I've taken 11.11 meter per second. So 11.11, how many? If you can convert this into this in meter per second, to have conversion to what meter kilometer per what you can say hour. You can convert it by using your calculators. So if you want to multiply this, what you'll get? Kilometer per hour. So you have to divide 3600,000. Okay. So if you convert it, you'll get around 40. So I've done this calculation. You can check it on your side. Okay. Anybody's having calculator, or we can do it afterwards. No issues. So you can have 40 and you can then convert to meter per second. So active force is nothing but all the forces multiplied by velocity. Velocity 40, and what will add all the forces and we'll try to find out. So I've done this calculation. You can see here that FT is 170 and total power for 40 kilometer is P is 1890 watts. Okay, so this is your power calculation. Come to this, and then I will also show you the Excel sheet of this. So this is speed graph of your electric vehicle. Power versus speed of your electric vehicle. Power consumption, your speed. So you look at, if you go on increasing the speed, what will happen? There will be more and more power consumption of your electric vehicle. So what do you think? Whether to drive at or you have to drive in 80? So the best speeds for electric vehicle will be 60 to 80. Your electric vehicle will give you maximum for your speed. Okay. So this is just for you that I will give you later. I will show you the Excel sheet now. This is your case study of your electric vehicle. Now, whatever we have inputted, I have converted that to an Excel sheet, and we'll do some calculation here. Can you see? Can you see this? Just put hi, yes, no, chat. Excel sheet. Can you see this Excel sheet? Okay, yeah, thank you. Okay, so we have taken 1000. So I will Excel sheet afterwards. You can contact me. I will give you Excel sheet. So what you can do here, you can play with this. I have already set up all the values. What you can do is you can select mass, width, height, then rolling, air density, track coefficient. So all these things, whatever here, I have just just copied that here. So you can compare between two vehicles. So what we'll do, I have to select a weight of 1000. So you can modification of my vehicle to say 800 kg, 1000 kg. Let's see what calculation differences I get. Okay. And I increase the speed to 60 here, or I can keep same speed, whatever you can decide here as per your requirement. And you can see that after entering, it calculates your rolling resistance force in terms of watt. Okay, how much? 196 watt, 34 watt, 1701 watt. So if you just add all the forces, okay, you'll get tractive effort. Got it? And you can calculate total power for 40 kilometers. Getting it? So 40 kilometers is what? 40 kilometer per second speed. So now here value will be different. Why? Because H12 is what? 16 kilometer, correct? So meter per second to uh, kilometer per hour calculation, we have to multiply by 1000, divide by 30. And if you look, see that there are different values what you get. What is the observation? Though your vehicle weight is higher here and speed lower, correct? Weight is more, speed is less, you are getting. And you can see that the vehicle 2 weight is less but speed is more, only more by 20 kilometer per hour. But you can see what is between this and this. So there is large difference in between the wattage of your force, correct? So if you look at for hill climbing, you can see that 2004 is more requirement. So upon this, if you select a motor, you have to look at all this tractive force of this to select a motor. So to select, if you select a motor of 10 kilowatt, for example, correct? What is the size of motor? 10 kilowatt. So what will be the current and voltage requirement? If you just have a motor of 10 kilowatt and take the tractive effort, whatever you got here, and if you put the voltage 360, so normal you have a battery which is giving output of 360 or 380, whatever values. You can also take 220 as value. You can find out what is the current which is required from this motor. Okay, so you have to this motor on what parameter? On this. Got it? So this is your, so force multiplied by your velocity will give you what? Power. Got it? So this into the, is this clear? So I will share with you this Excel sheet. So from this you can find out power, total power requirement. If you have a motor, you can have a battery and you can have current. Now depending upon this current, you can further find out battery cell requirement. How to find a battery from this current? So you have to select a battery which can give this current for how many hours? Say 8 hours. So battery, if you go to battery specification, your battery specification come in ampere hours. Okay. So it is it is beneficial if you have a single battery of this capacity, which will be equal to this multiplied by, because it's in our, you're not getting. Okay. So around 3000 will be your battery, 3000 ampere hour battery you will require for this calculation. Is it clear? So this is how you can design electric vehicle. So all the electrical parameters look at, you can make some change here according to your measurements, and you can add it. If you want a higher hill climbing, if you have more than 10 degree of slope, let us take 45, which is the steepest slope, you will get higher calculations here. See here. Automatically this will change. Get the values. So this is very high requirement. Climbing requirement is very high compared to this. So this is regular power requirement. This becomes not only 5 times, 10 times, it becomes 20 times of your actual values. So I think I have finished. Let us have some 5-10 minutes for question and then we'll stop. Okay. So what are observation? So huge variation in your vehicle is fully loaded to unloaded condition you can find out. So you can in hilly conditions, as I have told you right now. Then we can find out vehicle speeds, how your power calculation vary. While your vehicle power calculation, you can also have extreme conditions considering 20% overload or loading of your electric vehicle you can do. Okay. So in order to have loading, if your vehicle is this, you want 10% loading, you have to increase this by 10%. Your calculations will vary. Is it clear? Okay. So I think I have almost finished. I will just quickly go through this and then we'll stop. Okay. So, dv by dt is acceleration. So you can
Sir?
okay. I think I have finished. If you have any questions, we can take or we'll end.
Any questions from students? Hello? No questions, sir. Thank you very much, sir.
Yes, madam, you can continue.
Thank you very much, sir, for giving informative
Thank you, sir.
session. Hello? Now,
Hello. Yeah. Thank you, ma'am. Thank you. Yeah. For
I
being
would-
here. Yeah. I would be very thankful to college principal sir, then Wangankar madam for this effort, and Musa sir and all my colleagues for this opportunity for presenting this topic. Thank you all. Thank you.
hello.